So welcome to using DrawDebugLine, a very handy tool. In this video, we're going to show you how to add vectors. We'll be calculating our line trace endpoint, the end of our laser vision. We'll be using debug functions for visualization in Unreal. That's the whole point here. And we'll use DrawDebugLine to visualize the vectors that we're playing with. The purpose of this, by the end of it, you will have a situation where if we come out of the player's body for a moment, you can see that there's a red line that points wherever the player's looking. If I repossess the player and look down and maybe move near the chair, like something like that, and then come back out of the body, you'll see that we can visualize where the reach of our grabber is, and it's really handy for working out what's going on. So in order to draw our line trace in the world, we're going to need to know the start point and the end point of it. So to do that, we're going to need to know a little something about vectors. So here's a quick primer on adding vectors. So if we have some vector A, like that, just represented as an arrow, like our player viewpoint location, and then we add to it some vector B, like our laser beam coming out of our eyes, then A plus B is that vector there. You simply add the tail of one to the head of the other, and the resulting vector is just the sum of the two journeys. A took us to the point at the top there, B took us down and to the right, so A plus B, the result of those two journeys, is that overall green line, the bottom line. Okay, so how does this apply to our player viewpoints and things? Well, we are wanting to calculate line trace end, so we know where the system needs to draw the end of our tractor beam. So what do we got? We got player viewpoint location. That's just three numbers that tells you where the player is relative to the origin, which is at 0, 0, 0. So we're already dealing with and logging out player viewpoint location, and that's pretty simple. There it is. It's represented by that yellow arrow. Another thing we've already got hold of is the player viewpoint rotation. But that is stored as a rotator, and in order to use it like a vector, we have to convert it to a vector. So player viewpoint rotation.vector there just converts our f rotator into an f vector. And we could store that in something like line trace direction. That tells us the direction in which we are going to trace our line, or the direction in which we're looking. They're the same thing. Okay. The only thing with that line trace direction we've got there is that it is something called a unit vector. When we've asked for the player viewpoint location and gone dot vector, we've just got a vector of length 1, which is fine for telling us the direction, but what we need to do is multiply that by the reach. How far out are we going to be able to reach? Is it 1 meter, half a meter? Depends how long our arms are, right? So line trace direction times reach is the resulting vector from our eye viewpoint at the top there out to the end of our hands. So the question is, what is line trace end? Well, by referring to the previous slide, that should be pretty simple to work out. But before we go ahead and do it, let me set you up with something very useful that we can use to test whether you've got this right before I put you into the challenge. So here we are. What we want to be able to do is visualize in the world, at least when we eject, we want to be able to see something sticking out the front of the player, a bit like that vector. Look, imagine the origin of the world is down here on the left for a minute. There was that vector player viewpoint location, and then we want to look down here. So we want to be able to actually visualize this. How are we going to do that? Well, let's go over to the code. There's something very useful. I'm going to put another line in here. Yes, we're logging out to test, and that's fine. We can continue doing that, or we can just comment all of this. Now, one way in Visual Studio is to hold down Control and push K, and while still holding Control, look at the bottom left, you can push Control C. So you hold down Control and then push K, then C. And that will comment that entire block out. So we're no longer logging for the moment, but what we can do is draw a red trace in the world to visualize. Okay, I'm going to temporarily put in the end point. So let me make a temporary variable for the end point here. I'm going to call it f vector, and then you can finalize it in your challenge. F vector line trace end equals, and let's just make it for the moment, the player viewpoint location plus, I'm going to make a new f vector here, and then I'm going to make it 0, 0, and then say 20 centimeters in the Z. So it should draw a line going straight up based on what we've talked about before. The end of the line trace is our viewpoint plus 20 centimeters up. So the method you want to use to draw a debug line just in the editor is this. Draw, it's pretty cryptic, debug line, pretty cool. Let's open the brackets, give ourselves some space because there's lots of parameters. What does it want first? It wants a world. It wants a pointer to a U world. Look, U world star. So how do we get that? Well, just get world. And that's just going to return the world. You see, it returns a pointer to a U world. Wicked. Next parameter, the line start. Well, let's draw the start of our debug line for now from the player viewpoint location. It's an F vector, right? We're all happy? All friends here? That's cool. All right, what's going to be the ending point? Well, I'm going to define here an ending point temporarily for you as line trace end is player viewpoint location plus a new vector, which is 0, 0, 20. So the endpoint is going to be 20 centimeters above the player's head because of the vector addition we talked about a moment ago. It's the viewpoint plus 20 centimeters up. Okay, so we're going to trace to line trace end just so we got this working. The idea here is that I want you to have the line tracing working before I put you into the challenge to actually get the reach working properly, and then you can tell it's working. Okay, now it wants a constant F color and color. Well, what's that? Constant F color and color. Lots of weird things going on there. We're seeing an ampersand. We've seen those a couple of places. That's something called a reference, which we'll go into in a little more detail shortly. But basically, you can treat things that are a reference very much like the original object. So don't be too off put by that. But what we need is an F color. So we could construct one, F color, with the American spelling, no U's here. And you just open the braces, and it's going to want something like RGB. Now, you can click through the different signatures. And one of them here will just simply be RGB. Here's a constructor that just takes RGB. In fact, that's the one we want. Constructor number 3 here in my Visual Studio. So I'm going to go 255 for the red. I'm going to go 0 for the green, and I'm going to go 0 for the blue. So it's going to give us a pure red line. Okay? I'm not going to comment that because it's going to go out of date the moment I change those numbers, but that's the color. What's the next parameter that it wants? Well, we're going to need to wait for the autocomplete to catch up. Here we go. Do the lines persist? So we're going to draw a line in the world to see which direction we're looking, but we don't want them to persist in this case. That is from one frame to another. They're just going to disappear immediately and be redrawn every frame. So we're going to say false. What's the lifetime it's asking next? Well, I don't care. So I'm going to say 0 because it's not persisting. Lifetime is not relevant. And the depth priority is to do with the priority with which this is drawn in terms of depth filtering. Does it draw in front of or behind other things? We don't care for now. 0 is fine as well. Okay. Cool. Little semicolon on the end of that. And that is just giving it all the parameters it wants. Let's try building, see what happens. What I'm hoping is we're going to get a red line. Oh, I've missed one parameter, haven't I? I didn't give it a thickness. You see it was asking for thickness. It's happy without one, but I'm going to make the thickness, say, 10 centimeters. Okay, and just rebuild. By the way, with building, you see this file isn't saved here in the IDE. If you go over to Unreal, even without the file saved and click Compile, go back to your IDE, you can see that it has actually saved the file for you, and it's compiling. But of course, we have a compile fail. So let's see what the problem is. Literal suffix F operator on line 59. You can get your errors from Unreal too. Let's go see what's wrong with that. And it's because if you're going to have a float, you've got to put a decimal in it. Again, I could go back to Unreal and compile from there. This time we should get more joy. That's it. Now we play. Now I can eject either by hitting the eject button, or you can see the short key there. It's F8. If I zoom out, then do we have a debug trace either inside? Yeah, we do, but it's inside our bodies. And that means that 20 centimeters is simply not enough. So let's do the hot reload. I'm still playing here. You see, now I'm going to pop back to the IDE. I'm going to make the length of this vector here above your head more, like 50 centimeters. I'm going to go back to Unreal without even saving and just click compile while we're running. It's going to do what we call a hot reload. Here you go. Now, because we're quite big, 50 centimeters just sticks out the top, but it is sticking out. Cool, so now we have a vector from the center of the sphere sticking out the top. You're now ready for your challenge. Here's your challenge. So calculate line trace end. I want you to create a private variable, float reach equals 100f, 100 centimeters to start with. I've kind of done that for you. Just put it in the right place in the right file. Calculate line trace end through the simple vector addition. I've set you up for it. You may need to recap the last couple of slides or early in the video. Test the debug trace, eject to visualize like I just did to make sure it's working right. And then share in the discussions why, from your point of view, when you're inside the player, it looks like a square. From the outside, it'll look good. But why from the inside does it just look like a square? Share that in the discussions, and I'll see you in a moment. Okay, welcome back. So the line trace end that we actually want is the player viewpoint location per the slide, plus the player viewpoint rotation, dot vector times reach. Okay, now I need to make something called reach. So we're going to go to the header file, which is one way to get to it, is to go drill in here to source, building escape, grabber.h. Down in the private section, I'm going to make a comment first so that it's self-documenting. How far, what do we say? So how far ahead of the player can we reach in centimeters? And then I'm going to go, I don't need to say private, I just need to say float. Whoops, this is an edit after the fact. Looks like I failed my own challenge here. Of course, I do need the word private, so please go ahead and put private colon above. I'll add that in a few lectures' time because to do it now would mess up my code history. So well spotted if you saw that. Reach, which I've copied, equals 100f to give it an initialization. Now back in the actual implementation file, reach should work absolutely fine, and this is basically ready to go. All I've done is taken the player viewpoint rotation times the reach and added it on. Now you can put all this in brackets if you want. If you're in insert mode, you can put it in brackets. But because of BODMAS, you may have heard of the precedence of arithmetic operators, the star here will bind, the multiplication will bind more strongly than the plus. So it's going to do it this way anyway. So strictly speaking, you just don't need the brackets. But if in doubt, stick them in. Okay, let's build. It's running the header tool. Skibbity-bibbity. Okay, so we've got a problem on grabber.h25, and I've done the same thing that I did before. You need the decimal before your F, okay? Rookie error, let's go back into Unreal and compile from there. It doesn't really matter whether you build from Visual Studio or compile from Unreal, it's the same job. Unreal is reaching into Visual Studio and doing that compilation for you. Actually, so I'm actually already ejected and running, and look, it's straight out in front. Now, if I repossess and look around, it's just a square. You're going to explain in the discussions why that's the case, and that's because we're looking straight down that vector. If I F8 to unpossess and come out, it's because our camera is right in the center of this, looking straight down that debug trace, and that's why, from that point of view, it just looks like a square. Okay, congratulations, that's massive progress, and I will see you soon.